Welcome to Get Your FRQ On. This question is from the 2006 test, Form B, and it is question 2C, which means it is calculator active. In the given information, we're provided a graph of f prime of x and not a whole lot of other information. You can look up the question using the link in the description. But in part A, we are asked to use the graph of f prime to determine concavity of f on the interval from 1.7 to 1.9. Now, the way we would do this is, even though normally we associate concavity with the second derivative, we don't really know much about the second derivative. We're not given a formula for the second derivative. We're not given a graph of the second derivative. The only thing really that we have is the graph of f prime. So we have to make a connection between the graph of f prime to the information we want to get about the second derivative of f so that we can make a determination about the concavity of f. And this is pretty typical. In order to justify our conclusions here, we have to use the information that we're given. We can't just talk about the second derivative of f as if it's something that we know. We don't know it. We do know the graph of f prime though, so what we want to do is establish a connection in our reasoning between the graph of f prime, properties that it has, and how that corresponds to properties of the second derivative that we would need to discuss. All right, so in order to determine the concavity of f on this interval from 1.7 to 1.9, we need to know something about the second derivative of f. We don't know much about the second derivative of f. In fact, we know almost nothing about the second derivative of f, except what we can infer from the graph of f prime of x, which we are given. We must use the graph of f prime as the basis for our justification, since that's all the given information that we have. Well, based on the graph of f prime in the question, we can tell that f prime of x is decreasing on the interval from positive 1.7 to 1.9. Okay, well, if f prime of x is decreasing on this interval, that means the second derivative of f is negative on this interval. And if the second derivative of f is negative on this interval, that's how we conclude that f will be concave down on this interval, because we can say something about f double prime based on the graph of f. We do know that f double prime of x will be negative on this interval, and therefore we can conclude that f will be concave down. In part B, we are asked to find the absolute maximum of f on the interval from 0 to 3. Well, on the interval from 0 to 3, the graph of f will have an absolute maximum either at one of the endpoints or somewhere in the interval from 0 to 3 where f prime of x is 0 and changes sign from positive to negative. All right? We are given a formula for f prime of x. It's not one where I think we would be expected to understand what that graph would look like, but we are provided with the graph, and it is a calculator question. So we do know based on the graph what this function looks like, and if we do need to do any specific computation here, we can use our calculator to find values for f prime of x if we need to. Well, if I need f prime of x to equal 0, and I know that f prime of x is e to the negative x over 4 times sine of x squared, that's only going to be 0 when either e to the negative x over 4 is 0, which is never going to happen because the range of e to the x is all positive numbers, or when sine of x squared is equal to 0. Well, sine of x squared will equal 0 at various multiples of pi, or at least if x squared is multiples of pi. So x squared will equal 0 or pi or 2 pi or 3 pi if x is equal to square root of pi, square root of 2 pi, square root of 3 pi. And I just noticed this is a typo here. That should be just x, not x squared. All right, so x can be any one of those numbers, 0, square root pi, square root of 2 pi, square root of 3 pi, and so on. However, we're only concerned about the interval from 0 to 3, so most of those values we don't really care about. It turns out the only value on this interval, 0 to 3, for which f prime of x is 0 and also changes sign from positive to negative is x equals the square root of pi. All right, so now we have 3 candidates. It's either going to happen at one of the endpoints, 0 or 3, or it's going to happen when x is equal to the square root of pi. All right, now because this seems like an extreme value theorem problem, when there's an extreme value theorem problem in a free response question, you absolutely must check the endpoints, as well as any of the candidates in between the endpoints that satisfy whatever property you need for the derivative. So we're going to check f of 0, f of the square root of pi, and f of 3 to determine which of these is actually the absolute maximum of f on the interval from 0 to 3. All right, so we're given in the question stem that f of 0 is 5, right, simple. F of the square root of pi we can find by integrating and doing f of 0 plus the integral from 0 to square root pi of f prime of x dx. It's a calculator problem, so this is something you would be expected to actually calculate using your calculator. When you write your response here, make sure you include the integral expression that you're asking your calculator to evaluate. Yes, it is a calculator problem, but the reader scoring your exam needs to know what calculus you asked your calculator to do for you, and that's why writing this integral in your response is so critical. If you don't write it, you will lose points, and there's going to be plenty of opportunities to lose points on free response questions. You don't want to be the student who simply gives them away. All right, so f of the square root of pi, we can calculate using our calculator. It's about 5.679. Likewise, we can find f of 3. That's going to be f of 0 plus this integral from 0 to 3 of f prime of x dx, and that turns out to be 5.579. All right, and so now we have a comparison between all 3 of those function values. F of 0 is less than f of 3, and f of 3 is less than f of the square root of pi. And based on this, we can conclude that the absolute maximum value of f of x will occur when x is equal to the square root of pi.